Hello all. I am Atharva Patwardhan, team leader of team, not like us, and we have chosen the problem statement first, track one, marine fouling, for the Code Wars Hackathon 2025. So I'll just get you through a quick solution what we have built or what we are trying to build. So let's get started. So, what is the problem statement? What exactly is marine fouling? So, marine fouling is basically where algae and other organisms stick to the hulls of ships. It's majorly a challenge in the shipping industry today because of the large algae growth in the hull of the ship. There is a lot of issue regarding the raise of carbon emissions, demands, frequent expensive maintenance, etc. So the traditional methods like manual inspection and chemical coatings are either too costly or harmful to the marine systems or reactive than preventive. So what we are trying to build is a not complete, but a majorly software-based solution, which is a cheap alternative to this lengthy process. So I'll talk about our innovation right now. So basically, we are building an intelligent end-to-end software-driven solution that not only detects fouling but also classifies its stages. For example, a human eye can't tell if the algae is big enough or it's in a growth stage. So for that, we use CNN machine learning algorithms to classify the stage of the algae before even its growth starts. So I'll tell you how we'll do this. So our solution is that first we'll capture the image with a remotely operated vehicle, that is ROV. So the ROV will be built with Arduino Uno or Raspberry Pi, and it will be mounted with two UV cameras and UV lights. So we can also use a normal camera because we are placing the UV lights in the ROV. So an underwater ROV will capture the RGB plus UV lights and will scan the ship's whole hull and capture the clear geotagged images. So next part is pre-processing of the data. So the images that are collected by the ROV will be monitored by our software for underwater distortions using dehazing, denoising, and decolor correction and color correction for better visibility. So as you know that there is no much sunlight deep in the ocean. So for that, our images are corrected by our software using our various techniques of improving image. So third is fouling segmentation and density detection. So our specially designed machine learning models and deep learning models like CNN UNet identify the fouling regions and calculate the density percentage across the hull surface. So why we are doing is basically for the identification at what stage the algae is and when needs to be cleaned. So fourth is species growth and growth detection. So the AI classifiers labels fouling species into categories like algae, barnacles, and it's also stages early, medium, or severe. And we have also made a complete dashboard telling the fouling index less fouling score. So this gives an combined index for evaluating drag, fuel penalty, and operational risks to prioritize the critical areas and schedule the predictive maintenance. And sixth is the predictive maintenance engine. So in this time series forecasting predicts future fouling goals and suggests optimal cleaning schedules to minimum cost. So for example, my ship is in the Pacific Ocean and I know that there's a lot of uh, salt content and mineral content in that ocean. So our system intelligently creates a heat map around all the oceans and tracks where mineral count is high and where there is a chance of higher growth of algae. Last part is the main innovation and the USP of our solution, which is 3D hull mapping and AR visualization. So, for example, it's not friendly for everyone on the ship to use a machine learning dashboard or to check the details of the algae on a website. So, what we are doing is we'll create a complete 3D model of the ship, mapping the hull, and will show the fouling hotspots from red to blue. Red means severe, blue means good, cleaned. In a proper heat map on the ship, so that the workers will exact know where the algae is, and they can schedule the cleaning process accordingly. So for front end, we'll be using React.js and Tailwind CSS. For backend, we'll be using Node, Express, and Python. So for the computer vision and augmented reality features that I just mentioned about the 3D fouling, we'll be using OpenCV and Unity. And for density detection of the algae, we'll be using YONO unit. So for forecasting, we'll use Meta DeepLab 5 and LSTM. And for the IoT part, the ROV will be used with Raspberry Pi and waterproof camera like GoPro with UV lights. So as you can see, this is our detailed workflow. So what are our challenges? We have designed the solution in such a way that there are not much challenges present right now, but there are two to three challenges which I'll explain. So unclear underwater visibility. Though we are using UV lights and high quality cameras, due to the dark waters, biofilm and poor lighting reduces the image clarity, making fouling harder to detect. So limited training data for biofilming. As we all know, there are very few publicly available data sets for algae barnacle species. So we have to create our own data set of the images. And third is real-time integration. So running an AI detection prediction and 3D AR visualization together in a ship where internet is low is resource intensive. So what we have planned to overcome these challenges? So we will use ROV mounted with UV/LED lighting that will capture the image in dark water also. Second is limited training data. So will use synthetic fouling images, data augmentation, and transfer learning to improve AI accuracy across species and growth stages. And third is for real-time integration and scalability. We use lightweight AI optimized model, which not only handles the detection and prediction, but also manages AR efficiently. So for now, this is our solution. Thank you so much. We hope to see you in the offline round.